We've spoken a couple of times about the brain of the application. We refer to the brain as the variables, constants, and functions that are placed above the body inside the content view. So far, our applications have been quite simple, and we haven't really needed to worry about the length of the code or the understanding of the code due to the amount of code that we have. A data model is used to collect pieces of data and group them into one object. So in programming, the model isn't necessarily what you see on the screen. Although some of the information contained in the model will be placed on the screen, the model is more of a template that describes the data that we're collecting. And then we can use that template to actually group all the data we're collecting into one object. So take, for example, a student. We would have a student that has a first name, a surname, gender, and a date of birth. Now, that information could be stored as multiple variables. You could have a state variable for a first name, a state variable for surname, and so on. However, as we get along inside the program, we're going to want more than one student. So when we have 4 variables for each student, if we have 20 students, that could be quite long, confusing, and very difficult for us to use inside of our view. In addition, we might have a variety of functions that relate solely to a student. So for example, we have date of birth, we might have their year level, so they would have, say, a graduating year, and from the graduating year we can work out what year level they're in. There are a number of different things that we may need that only relates to that one student or that one type of data that is a student. Within an object, we have what are called properties and methods. These are quite simply the variables and functions that are contained inside the data structure, which is known as a class. So once we have our template, we can actually create multiple students as many times as we want, and we can actually call that student using one variable name rather than multiple variable names. And you'll see that in a moment. So on the left, you can see what would be a student that has been described using multiple variables. Student 1 first name, student 1 surname, student 1 gender, and so on. As you can see on that left-hand side there, it gets quite long and we haven't even got too far through the number of students. So we can eliminate all those variables by grouping them into one object, one class called student. And student will be an observable object. And that will actually allow it to be the equivalent of a state variable. So when I create a student and we give them a first name, surname, and a gender, they will be able to be used as a state variable that will update the view when it is changed. So if I change the first name or I change the surname, the view will be automatically updated. So that's an observable object. In this example though, we would get an error. And the error is that student has no initializers. So when I'm creating the student, we need to be able to get information from the code that will actually be placed inside of the class. So we use what's called an initializer, which runs when the object is created. So we've done this before in our rounded rectangle. We'd have a rounded rectangle and it requires a corner radius. And the corner radius is a CG float where we put in a number. With a student, we need something similar. What value will the first name, surname, gender, and date of birth be? We have to be asking for that information when we're creating our student. So the initializer here is fname, sname, gender, and DOB. That's what's going to appear in what we refer to as the helper. So normally we'd do a rounded rectangle, for example. We'd do rounded rectangle, open brackets, and wait for the helper. this will do the exact same thing. When we say student, open bracket, this will be our helper, fname, sname, gender, and DOB. So when the person types in that information into the helper, as you can see, it's going to ask for the information. When we type it into the helper, we have to assign those values to one of our properties, one of our variables. So in this case, first name will equal the F name that is typed in. Surname is the S name that is typed in. Now, gender is slightly different. Because gender has a property inside of the class already, the gender that's in the initializer needs to be distinguished. So we put self.gender to refer to the gender that is inside of our object. So var gender is self-gender, whereas the gender that's in black in the code is referring to the gender from our initializer. So self.gender is going to equal the gender inside of our object is going to equal the gender from our initializer. The last one, date of birth, doesn't need self because date of birth is not the same as DOB, even though the values are the same and they'll be assigned to that. DOB is not the same as date of birth, so I don't need self, whereas the name gender is the same in both the initializer and inside the object. So this is what it looks like when we call a student. So we would write this in the brain of our application above the body inside of our content view, and we type let new student equal student, and we'd open the brackets, and you'll see that the helper would provide this information as you would with a rounded rectangle with a corner radius. So if we were typing this out, we would say let new student equal a student with an F name of John Smith, male, and the date of birth I've just thrown in the current date and time. If I want a second student, I can type let another student be that information, and a third student if I need another one. Now this is far cleaner and far easier than calling each of those variables individually. If I also write this without classes, there would be a variable for each first name of each student, and each surname of each student, and each gender of each student, and each date of birth of each student. Again, we've translated what would be in excess of 30 lines of code into 3. So the model is essentially a separate file. We don't have to put it inside of our content view. As long as we make it inside the project, inside our Xcode project, we're able to use the model inside of our content view. So it becomes the content view becomes a bit of a middleman between what the person sees on the screen and the data that's in the back end. So the content view can call upon the model and ask for the template and ask for those functions. So if we're adding this to an existing model to our project, we can actually just drag it directly in to Xcode. So if you were to download, say, the clock model, and it's in your downloads folder, you can see in the Finder at the back of that image, you can drag it directly from Finder into the folder for your project. The big tip though, when you actually drag it in, it'll give you this box, and you have to really make sure that copy items if needed is ticked. Otherwise, it's simply a reference to the file that's in your downloads folder. So if you delete that file from your downloads, it will delete it from this project. It won't be available. Whereas if you copy the file if needed, as in if it's not already in your project, if you tick that box, it'll make a copy for your project separate to the downloads folder. You can delete the downloads afterwards. So if we're making our own model, you can hit the click on the folder for your project. This is just to make sure that the file that you're creating goes into that folder. And then you hit the plus sign in the bottom left-hand corner, choose Swift file, and hit next. We've done this in the past with a new view where we've gone a new Swift UI view. This time we're choosing a Swift file. The only difference between the two is a Swift UI view gives you that templated content view style structure. Var body is some view and so on. It's important to give the name of the model without spaces. Our file names, our models, they don't work well with spaces, and it's best just to remove them. And in this case, because the class is not a variable, it is a data type, we have a capital for the first letter and then the remaining camel case as normal. So if we're calling it now, we've created an observable object, and they, as I said before, are exactly the same as what would be a state variable. The only difference is the way we call it. So rather than saying at state, we use at observed object. And in this case, I'm importing our clock model, and at observed object is going to be a variable clock, which is going to be equal to a clock from our clock model. Once that's been declared, we're able to call the data that's inside of our clock. So in this case, the clock actually has a property called stopwatch display, and we can simply put that inside of our text field. Now, when you actually type clock dot, you'll actually get all the helpers as you normally would, including those properties that are inside your model. So in this example, we have a clock type, which has properties, which are the current date and time, an array of lap intervals, whether we're creating laps, the lap display. There's a whole heap of functions that are in there that we can use because that's what's inside of the model. That's what's inside the class clock, and I can call them anytime I want.